Section 4.2 is dealing with simple formulas and literal equations. So literal equations do seem like they're a little fancier than a regular equation, but the truth is it's just an equation that has more than one variable. And we end up with a lot of equations in the technical fields that have more than one variable. And sometimes you'll have the equation solve for one variable, but really you want to solve for another one. And so we would solve these literal equations so that we could find the variable that we're looking for all by itself on one side of the equation, and then everything else, including other variables and constants, would show up on the other. So we'll rearrange the equation so that the variable to be solved is on one side of the equal sign, and then everything else is on the other. And then there's a little golden rule of algebra. So you might know the golden rule, do unto others what you would have them do unto you. Well, it's the same thing in algebra. What you do to one side of the equation needs to be done to the other side of the equation in order to preserve equality. So really, everything that we did in section 4.1 with solving equations all applies here. It's just we'll have more than one variable. In example 1, we're trying to solve for c. So that's the variable that we need to isolate. Everything else can stick around. So if I want c all by itself, then the operation that we'll do here is subtract 273. But since k and 273 aren't like terms, then we have to do k minus 273 and leave it together without combining and set that equal to c. And that's our equation. We could write it like that, or we could flip-flop and write c equals k minus 273. In example 2, we need to solve for b. So again, we find the variable that we're looking for. Right now, I have ay plus b, and if I want b by itself, I can subtract the entire term ay, and those will cancel, leaving me with just b on the left. On the right, I cannot combine 2c and ay because they have different variables, and so I will just combine them as an expression, 2c minus ay, and we're done.